Hello everyone, welcome back. In this video, we're going to do something different. In many of my earlier videos, you have seen me using this kit that I've kind of put together using one of the off-the-shelf kits that I use for these demos. And I tried to put as many of the components that came in that kit all packed in this box and I have also talked about this library, really not a library, it's more like a collection of classes that I created by curating libraries from different parts of the internet that allow all of these hardware to work together. So today I'm going to introduce to you this library that I call PicoLibrary, which, as I said, is just a collection of classes designed in an object-oriented manner that get all of these hardware together. So here is a simulated version of this kit that you just saw on the screen. It is not exactly the same, and yeah, it does look a little scary, but I tried to cram all of the things that you saw on that kit, and at least as many of those that could be supported by Walkway. What I'm going to do is I'm going to show you guys a few of the classes, and let's see how many I can get done in my self-imposed limit of about 30 minutes or so that you get a good idea of how this library is put together and how to use this library. All right, so what library are we talking about? This is, of course, the Pico library. I will link to this video description as well as this is the same library that we have been using for many of my demos in this video series. Um, there is a description of the library, and I know there are some typos in the description as I was preparing for this video. But as you can see that I have created a collection of classes all around the Raspberry Pi Pico hardware interface. Let's see how to use this Pico library. So unlike a Python library where you just say import library and you can start using any of the classes from that library, this is really designed to be a kind of an a la carte set of classes instead of pulling the entire library. The reason for that, of course, is that the Pico is a small microcontroller. You do not want to load an entire library into the microcontroller. You're going to run out of space and you're going to run out of memory. So you would really want to only load the classes that you would like to use. So let's start with the class that you would absolutely need to load to use any of the library classes. And that class is called the log class. And that's, of course, most of the classes in PicoLibrary use this class called log.py. So that's the first one we're going to load. And it really doesn't do anything. If you look at the log class, every class has documentation, so you can see what the class does. You can set up a log level. So the default is debug. That's kind of the global log level. If you do not want any logs at all, you can say log level equals none, and then you're not going to get any of those annoying log messages anymore. Sorry, the default is all. So every message that you ever do is shown. So the class log really has, I use kind of the Android style of logging. I is for info, D is for debug, E is for error. Those are the three that are supported. So if I run this and say from log import star, I can say log.I hello, and it says hello, right? I can say log.e hello, It says, hello, there is no difference between the two, right? But if I set log.level equals error, okay? So now if I say log.I hello, notice that nothing happens, right? Because the level is now set to error, which means anything lower than priority, let's call it, then error is not going to be shown, right? And if I say log.level equals none, no matter what you say, log is not going to do anything, right? So no log message is shown. If I put log level is back to all as usual, then log messages are shown again. Okay, so that's the class that everything uses. That's not all that fun. So let's look at our first hardware class, which we have seen several times, but let's quickly take a look and we will go quickly through some of these classes. So let's upload lights.py. All right, so lights.py creates several classes. The light class, which is the basic class for LEDs, the dim light class that allows you to dim LEDs. And those are the only two classes that are in this lights.py. So we will say from lights import star. And then in order to since this is an object-oriented library, in order to use any of these classes, you create an instance of the class and then you call methods to it. Okay, so let's first use a regular LED. This red LED is connected to my pin 6. So I can say red equals light, pin equals 6, name equals red. And there you go, it reports with a constructor. And I can now say red.on. And that turns the red LED on up here, as you can see. And you could review the methods. You can say red.off to turn it off. You can say red.flip to change its status to whatever it was, the opposite of that. You can say red.blink. So what blink would do is it's going to just blink the light with a specific delay. So if I just say blink, it's going to half a second on and then turn it off. You can actually send a value number of times you want to turn this on. So you can say times equals 3, and then it's going to blink 3 times. Right? So those are some of the light classes. Let's now use a dim light. So instead of showing it as a full brightness, what we're going to do, let's use the turn the red light on again so you can kind of see how that looks like. And now what I'm going to do is I'm going to turn the yellow light on. So we will create yellow. This time, instead of a light, I'm going to create an instance of dim light. Works kind of the same way. Obviously, the name is mainly used for logging purposes, and you would see that when you turn it on. So for example, if I say yellow.on, notice that it uses that name in the logs as well. By the way, these guys are all generated by the log class, right? So now the distinction between the dim light and the regular light is, of course, dim light is setting different levels of brightness. So there it is, the red light is just a digital light on and off. Dim light is basically turning on the yellow light at full brightness. Now I can change the brightness to a little lower version. So I can say yellow dot set brightness to maybe about halfway, which is about 120. And you would notice that the brightness of the yellow light goes down. I can go even lower. I can go to maybe 50. quarter brightness, and you would notice that it goes even lower. So the next class that we will introduce, very similar to the light class, is the composite light class. So a composite light, as the name would suggest, it basically a bunch of lights put together. So for example, we have introduced the traffic light class in a previous video. There is actually a traffic light class in here as well. So I'm going to upload composite lights, and there it is. So you have already seen traffic lights, but let's take a quick look at how that will work with this composite lights library. So I'm gonna run that, and there's the red, yellow, green. So I can say from composite lights import stock, and I can say TL equals traffic light. Let's take a look at the traffic light class here, which takes an R pin, Y pin, and G pin. And R is in pin 6, 7, and 8. So I can say R pin equals 6, Y pin equals 7, G pin equals 8. And notice that it turns red when you create an instance of the composite light. It by default sets the light to red for safety. And then I can say TL dot caution or go should turn green. There you go. I can say TL dot caution, that'll turn yellow, and TL dot stop, and that will turn red. And as usual, we can also say TL dot operate, just like we showed in the traffic light video. And that is going to run through a full cycle of the traffic light from green, yellow, red, and it stops there. So there is the traffic light class, which is in the composite light. Let's take also look at the pixel. And these pixels, these RGB LEDs, they come in two different form factors. Some of them are common cathode, some of them are common anode. So you kind of have to see in your documentation of the kit that you got, whether you got a common cathode or a common anode, and the connections will be slightly different depending on what you got. But basically, if you have common cathode, you put the cathode to ground and you drive the IOs via resistor to the different anodes. If you have a common anode, then you put the anode to a VCC pin, and then you kind of do the reverse logic for the cathode pins via the resistor. So it's much easier to deal with common cathodes. Like I have this one connected, the common pin is directly connected to ground, and the other pins are connected to the three different uh, colors. So let's create an instance of pixel, and it takes red pin, G pin, and B pin. Remember RGB, that's why it's red pin, G pin, B pin. And common cathode by default is true. If you have a common anode once, you're gonna have to flip that and make sure your connections are right. So in my case, these are connected to pins 3, 4, and 5. So I'm going to say from composite. Oh, I've already imported all of them. So I can say P equals pixel. This is pin 3, 4, and 5. I'm just gonna be lazy and say 3, 4, 5. Let's take a look at how it's set up. And the color is basically needs to be an RGB. So let's do P dot set color. Let's say 255.00. And there you go, you got a red light. And I can set the color to green. I get a green light. And if I set this to blue, I'll get a blue light. If I set all three of them to 255, I should get pretty close to a white light. Like that, and I get a white. And of course, you give it different RGB combinations to get different colors. Let's do something a little more fun now. Let's go to another light, which is this guy. This is, of course, a NeoPixel strip. Now, the kit that many of the kits come with a linear strip. The NeoPixel strip that is in Walkwe is this pretty circular 16 LED strip. So we're going to try to play with this one and see how this works. So to use the light strip, we need another class called light strip. So I'm going to upload file. Great thing about the NeoPixel strip is that you only need one I/O pin. It looks kind of complicated, but if you follow, this is that digital input line and it's coming from pin 2. So all we need is from light strip import star. And if you look at the light strip class, uses very similar. It takes a pin and a name, and it takes the number of LEDs and the default brightness. So what we will do is L equals light strip. Pin is 2. Name is Neo. Num LEDs by default is 16. We'll use all 16 of them. We'll turn it on to full brightness. Equals 1. Okay, so we created it. Now I can say L dot off. Notice that it turned off, which is basically all off. I can say L dot on. Works just like it's our regular light, right? I can say L dot blink. It's on, and then turn it off. But now let's do something that the NeoPixel can do, right? I did on, off, flip. I can set a color. Now here's the magic of the NeoPixel. I can say L dot set color. I think this light strip class has a few lights defined already. Yeah, here are some of the lights I defined here. So we don't have to, so I can say it's set color red. Now this entire light strip turns red. But I can also say L dot off, turn it off, L dot set color red to only maybe 5 lights. Then I only turn 5 of the 16 lights on. So that's kind of a cool thing you could do. You can individually control the LEDs. Now, what is also nice is you can individually control different LEDs to be of different colors. So that you use by calling set pixel. So you say L dot set pixel, and you give it a pixel number. So let's say I want to set this guy, which is pixel number 0, 1, 2, 3, 4, 5, 6. I want to set this pixel number 6 to green. So I can say 6 green. And notice that only that pixel gets set to green. I can set the one next to it to yellow. And then the next one becomes yellow. So you can actually create all kinds of things. You can turn them on, turn them off, create a chaser and things like that. Let's now move on to something that makes sounds, because that is also something that we use quite a bit in our demos. So we're going to upload the buzzer. Okay. So I just uploaded the buzzer. I'm going to refresh. And the buzzer class is pretty simple. It has an active buzzer subclass and a passive buzzer subclass. We're only going to look at the passive buzzer. It lets you play a tone, stop a tone. You can change the volume, and that's basically it. So we're going to say Um, and the buzzer base class has a method called beep, which just plays a tone for a certain amount of milliseconds. So it's very similar from buzzer import star, and we say b equal buzzer, sorry, passive buzzer. Which one should we use? Let's use this guy. This is connected to pin 16. I could give it a name. Yeah, see, passive. So now I could say b dot beep, and it plays a beep. I can say b dot play, let's say 1000. It should play a really high note, much higher than that beep. Now that it continues to play, so in order to stop it, I'm gonna have to say b dot stop, and it stops. And of course, you can set the volume. By default, the volume is set to about half volume, 0.5. And if you want full volume, you set it to 1. Talk about one other type of thing that's pretty common in many of the things that you would build using the Pico, using some kind of display. Now, the only problem is in order to support this library, I have had to incorporate some of the publicly available library files. So let's see how that's done. So in order to use this display, although this is just the I2C display, you would still need to upload all the libraries because my display class does include all of them. So let's first upload the files, and then I can talk about what is included. So, and you would see that in the library, there is a displays class and there is a graphic displays class. So originally I had put all the displays into one big giant displays.py, but that was not a good idea because I would run out of memory pretty quickly, even if I was only using one of the displays. So I sort of separated things out. So I've got 3 different display classes, actually. There's the basic displays class, there is the graphic displays, and then there is a graphic LCD. So different types of displays are implemented in these guys. So we'll primarily be using the displays class. So if you open the displays class, gets imported, you'd see that it needs, in addition to log, it also needs GPIO LCD, and it needs Pico I2C LCD. So we're going to have to upload those 2 as well. In fact, there's a third LCD API that those 2 use. So we'll need 3 different classes. So we'll need GPIO LCD, we will need LCD API, and we will need the Pico I2C LCD, all 3 of them. Although this is only I2C LCD, but the library supports both of them. So we will need the library files for all 3. But to use the display, just like any other classes that we have been using in this library, you create an instance of the display class that you need, and you call methods to it. So we're going to use the LCD display class, and there is pretty decent documentation on how to use them. So you would use, if you have the parallel version, notice that there are all these parameters that you would need for the parallel version. For I2C, you would only need SDA and SCL. So that's very, very simple. So what we're going to do is we will say from this. So we'll say from displays port start. And as you can see, that takes a little long to load. But now I can say display equals LCD display, and SDA equals SDA is connected to pin 0, and SCL is connected to pin 1. SDA is 0, SCL equals 1. And there the display just turned on its brightness. I can say L display dot show text. L. And there it is. The display is now showing hello world. So notice that no matter what class you use, using the class is very consistent. You create an instance of the class and you look at what methods are available and you call the method that you want. There are things like you could say display dot clear. That is going to clear the display, of course. One cool thing about this display class is this is not a graphic display. This is a textual display. So you can't really show graphics in it, but one nice thing is that you can actually show some symbols. If you want to create symbols, you have to create a very small bitmap. And there is in the documentation, there's a link that you can go to where you can create these custom shapes. For example, you can create a heart, you can create whatever you want really, and then you can display them. The limitation is that the library only supports up to 8 custom shapes for the display. Okay, you can't add more than 8 shapes. If you want more than 8 shapes, you're going to have to remove one or basically replace one of the existing shape with a different one. So let's just create a shape. I'm just going to use the one that is in the documentation. And basically what you do is you say display.add shape. I call it D here because that's the variable I was using here. But since I called it display, I'll say display.add shape. And let's create my smiley face. And you can put it in whichever position you want. It could be between 0 and 7. So let's say I want to put it in position 3. I can say in position 3, this array. This array is what is generated. That's the bitmap for your special shape. So there, my shape is now added. Now I can just put this smiley face wherever I want. I can say display dot show text. Now I would say that in order to show this shape at position 3, I will say chr3 and wherever you want. Let's say I want to show it right in the middle, row 0, column 7. There's my smiley face right in the middle. I can show it wherever I want. I can put it in the very end. Put it there. So you can put your smiley faces and your whatever shapes that you create wherever you want. But remember, there is a limitation to only 8 different shapes that you can use. Let's do one more before we end the video today. And let's take a look at a motor. Okay. So again, motors, you upload the motor file. Motors. Refresh this. So here is the motor that comes with, and this is the kit that I have, and it's a servo motor, and I have it connected to pin GB9, right? So we'll say from motors import star. And let's take a look at motors. This is a servo, so we will scroll down to where, as you can see, I've got implementation for steppers, servos, DC motors, all kinds of different types of motors. But here is the servo. And the pin number, as we decided, was pin 9. So we will say M equals servo. Pin is 9, servo. And then I can say M dot set angle. Let's try it. Let's see where 90 takes me. Oh, I guess it was by default to 90. Let's try 0. There you go. That's 0. And if I set it to 180, that goes all the way to the right. So servo motors does have a 180-degree field of rotation. You can't go more or less. So you can set somewhere in the middle. You can say 30. That's 30. You can set it to 150. That's 150. So you can play with motors, with servos. You can move things around. There are other things in here, for example, sensors. Since we are at it, might as well do the sensors. Let's upload the sensors file. And sensors have digital sensors as well as analog sensors. So for example, this one, let's see, there's the digital output of this is connected to GP11. So let's just use from sensors import star. Now, for the sensors, it only matters if you have a digital sensors or analog sensor. What kind of sensor it is, the only does not really matter, except that if you have a temperature sensor, you can actually calculate the temperature. So that is an implementation, separate implementation as well. But let's take a look at digital sensor here, and what we could say, S equals digital sensor, and that is at pin 11. And then I can just check S dot tripped. Right, it says sensor is tripped, it shows true. So if I want to untrip it, maybe remove, make it dark, and let's call tripped. This time it's false. So a digital sensor gives you only a true or false value. So notice that when the light is high, it gives you true. When the light is low, it gives you false. There is nothing in between. So it's only true or false. Now, if you want an analog sensor, if you want different values of the sensor, then you will need to use an analog sensor. And I do not believe I have the analog input of this one connected, but I have the analog input of this guy connected. Let me see. Yeah. On the Raspberry Pi Pico, analog sensors can only be connected to one of 3 pins, 26, 27, and 28. So that's why my temp sensor is connected to one, and one of the analog sensors, this is 127, is connected to this one. So let's connect an analog sensor. Let's say S equals analog sensor 27. Analog sensor. And it takes a pin and a name. So, probably AS is a bad variable to use. So let's call it a sensor equals analog sensor 7. And let's give it name test. Yeah, that was it. So now I can say a sensor dot raw value. Right, that gives me 16,003. And if I change this to really high value, let's get the raw value again. Notice that as the lux increases, the resistance of the sensor decreases, which means the resistance increases, so the value decreases. So, but the point is that you're going to get a whole range of values from an analog sensor. And if I turn this all the way down and I call raw value, I get a very high, almost 65,000. And if it's in the middle, I should get about 32,000 something, right? About 30,000. So that's basically how analog sensors work. It gives you a whole range of values that you would need. So that is kind of all the types of libraries that you would find. There is, of course, many that we did not get to in this video, but to keep it short, hopefully these were useful. I'm going to try to add another follow-up video to this. There are other types of classes in PicoLibrary that we will be using in our future videos as well. Hope this was useful, and I will see you at the next video.